Network security conversations often go sideways not because people lack good intentions, but because they lack a shared vocabulary for how networks actually move information. When a manager cannot confidently follow what a protocol does, what a control changes, or why a connection fails, decisions become slower and risk becomes harder to communicate. Networking knowledge for managers is not about memorizing every port number or tuning every device, because managers are not expected to live inside configuration screens. Instead, it is about understanding the core protocols and technologies well enough to ask the right questions, recognize unrealistic claims, and connect technical details to business impact. A manager who can track how identity, traffic flow, and trust boundaries interact is far better positioned to approve priorities, defend budgets, and respond calmly during incidents. The goal here is to build that confident mental model, starting with how networks are structured and moving toward the protocols and technologies that show up in real security discussions. As you listen, focus on the purpose of each concept and how it changes what is possible in a network, because that is the kind of understanding that holds up even as specific products change. The most important foundation is understanding that networks are built in layers, which is a practical way to simplify a complex system into parts that have clear responsibilities. The Transmission Control Protocol and Internet Protocol, TCP/IP, model is a common way to describe how data travels, with lower layers handling movement of packets and higher layers handling application meaning. You do not need to recite every layer name to be effective, but you do need to understand the difference between a packet being able to reach a destination and an application being able to successfully exchange meaningful information. A network can be up while an application is down, and that distinction matters when you are assessing risk and outage impact. It also matters because security controls often operate at specific layers, which changes what they can block, what they can observe, and what they can prove. For example, some controls block based on addresses and ports, while others understand application commands and user identity. When a manager recognizes which layer a problem lives in, they can steer conversations toward the right teams and avoid wasting time on the wrong assumptions. Layered thinking also helps managers evaluate vendor claims, because a tool that only sees one layer cannot magically provide complete visibility into another. Once layers make sense, the next step is understanding the difference between reliable connections and best effort delivery, because that is where many practical misunderstandings begin. Transmission Control Protocol, TCP, is designed to provide reliable, ordered delivery, which makes it common for applications where accuracy matters, such as web browsing, file transfer, and email. User Datagram Protocol, UDP, is designed for best effort delivery with less overhead, which can be useful for time-sensitive traffic like voice, video, and some types of lookup and streaming behavior. The manager-level insight is that TCP and UDP shape both performance and security monitoring because they create different patterns on the wire and different failure modes. A service that uses TCP may fail with clear connection errors, while a service that uses UDP may fail in ways that look like intermittent loss. Attackers also take advantage of these differences, sometimes hiding activity in traffic types that are noisy or harder to validate. If you can confidently ask whether an application uses TCP or UDP, you can often narrow down troubleshooting and security hypotheses quickly. This is not about being a network engineer, but about knowing the foundational behavior that many other conversations depend on. After connection behavior, the next manager-critical concept is naming, because humans use names while networks use numerical addresses, and that translation is both essential and attackable. Domain Name System, DNS, translates names into addresses, and it is involved in far more activity than most beginners realize. A user can type a simple website name, but behind the scenes there may be many DNS lookups for different services, content sources, and security checks. That makes DNS logs a powerful source of security visibility, because unusual name lookups can reveal malware contacting suspicious infrastructure or systems attempting to reach unexpected destinations. At the same time, DNS is a place where attackers can misdirect traffic by poisoning responses, abusing weak configurations, or registering lookalike domains that trick users. Managers need to understand that DNS is not just a convenience, but a dependency that influences availability, security, and incident investigation. They also need to grasp that changing DNS settings, intentionally or accidentally, can reroute business traffic in ways that look like outages or data exposure. When DNS is understood at a high level, managers can ask for the right evidence during incidents, such as what names were resolved, by which systems, and when. Naming connects naturally to addressing, because once a system has a name resolved, it still needs an address and a network path to communicate. Dynamic Host Configuration Protocol, DHCP, is commonly used to assign addresses and related settings to devices automatically, which keeps large networks manageable. The manager-level reason this matters is that DHCP is a control point for consistency and a potential point of failure or abuse. If DHCP is misconfigured, devices may receive wrong network settings, leading to widespread connectivity issues that can look like mysterious application failures. If attackers can introduce rogue DHCP services, they can attempt to redirect traffic through malicious gateways or intercept communication, especially in less controlled environments. Managers do not need to configure DHCP, but they should understand that address assignment, default gateways, and name server settings are often delivered through it. This awareness helps when evaluating incidents where many devices suddenly behave strangely, because the root cause may be a shared network configuration problem rather than many independent device failures. It also helps managers appreciate why some environments invest in device identity controls, because controlling who can join a network reduces the chance of rogue services appearing. With naming and addressing in place, managers should understand routing and switching concepts at a level that supports good architectural decisions, because networks are not a single flat space. Switching connects devices within a local area, while routing moves traffic between different networks, and the distinction affects both performance and security boundaries. Virtual Local Area Network, VLAN, is a common technology used to logically separate traffic on shared switching infrastructure, enabling segmentation without physically separate networks for every group. For managers, the important part is that segmentation is only real when the boundaries are enforced and the paths between segments are controlled. A VLAN design that exists on paper but has overly permissive routing between segments does not meaningfully reduce lateral movement risk. Routing also introduces the concept of controlling where traffic can go and through which choke points, which is essential for placing inspection and logging effectively. Managers should be comfortable hearing terms like north-south traffic, meaning traffic entering or leaving an environment, and east-west traffic, meaning traffic moving within it, because threats often spread east-west after initial entry. When managers can discuss segmentation and traffic direction confidently, they can better evaluate whether a network design supports containment or invites rapid spread. Once traffic can flow, filtering becomes the next manager-critical idea because it is the mechanism by which networks enforce what is allowed. Firewalls are a common example of filtering controls, but the important concept is policy, meaning explicit decisions about which traffic is permitted and which is denied. Network Address Translation, NAT, is a technology that changes how addresses appear across boundaries, often used to allow many internal devices to share a smaller set of external addresses. Managers should understand NAT because it affects investigation and attribution, since external logs may show a shared address while internal logs show individual device addresses. Filtering can be basic, relying on addresses and ports, or more contextual, considering the state of a connection, the application, or even the identity associated with the traffic. The key for managers is recognizing that filtering rules express business choices, not just technical preferences, because every allowed path exists to support some function. Over time, filtering policies drift if exceptions are granted without review, so managers need to understand that governance and periodic validation are part of keeping filtering effective. When filtering is understood as a living decision system, managers are less likely to accept vague statements like the firewall is in place, and more likely to ask what it allows, what it blocks, and how those decisions align with risk. As managers become comfortable with flow and filtering, they should also understand inspection at a practical level, because inspection is where monitoring and policy enforcement gain deeper context. Inspection can be as simple as recognizing patterns in traffic volumes and destinations, or it can be deeper, examining application data to detect known bad content or suspicious commands. The challenge is that encryption limits what can be inspected in transit, which changes where you can realistically observe content. Transport layer security, TLS, is the common mechanism that encrypts many connections, including most modern web traffic, and it protects confidentiality and integrity, which is crucial for both safety and trust. Managers should be able to articulate why encryption is necessary and also why it complicates certain monitoring approaches, because this trade-off appears constantly in security planning. If an organization wants deep content inspection, it may need to place inspection closer to endpoints or at controlled termination points, which has cost and privacy implications. If an organization chooses not to inspect content, it must rely more on metadata, behavior, and endpoint visibility to detect threats. Confident managers can navigate this discussion without falling into extremes, understanding that encryption is a requirement and that visibility must be regained thoughtfully through design. The web is one of the most common places where these concepts converge, so managers need a clear, high-level understanding of web protocols and the technologies that shape them. Hypertext Transfer Protocol and Hypertext Transfer Protocol Secure, HTTP and HTTPS, represent the basic ways browsers and services exchange web requests and responses, and the secure form relies on TLS. In practice, web traffic is not only human browsing, because many applications call web services through Application Programming Interface, API, requests, meaning web protocols are now the backbone of machine-to-machine communication too. This matters for monitoring because web traffic volume is huge and normal behavior includes many automated connections that may look suspicious without context. It also matters for security because web protocols carry authentication tokens, session identifiers, and data payloads, so weaknesses can lead to account takeover or data exposure even without malware. Managers should understand the concept of a proxy, which is an intermediary that can mediate web access, apply policy, and provide logging, because proxies are often central to web control strategies. They should also understand load balancing at a concept level, where traffic is distributed across multiple servers to improve availability and performance, because load balancers can be key visibility and control points. When managers grasp these web fundamentals, they can better evaluate risks like exposed administrative interfaces, weak authentication flows, and blind spots created by unmanaged web access. Email and messaging protocols are another area where manager-level confidence pays off, because email remains a common entry point for threats and a common channel for sensitive information. Simple Mail Transfer Protocol, SMTP, is used to send mail between systems, while protocols like Internet Message Access Protocol, IMAP, and Post Office Protocol, POP, are used by clients to retrieve messages. Managers do not need to troubleshoot mailbox settings, but they should understand that email involves multiple hops and multiple systems, which affects where security controls can be applied. They should also understand that email security is not only about blocking obvious spam, but about detecting impersonation, malicious links, and dangerous attachments, and that these threats often rely on social engineering rather than technical exploitation. This is where identity assurance and authentication policies matter, because if an attacker can impersonate a trusted sender or compromise an internal account, email-based attacks become far more convincing. Email also intersects with logging and incident response, because investigations often need to reconstruct message paths, delivery decisions, and user interactions. A manager who understands the basic flow of email protocols can ask for the right evidence and can understand why some controls live at the gateway while others live on endpoints. This prevents simplistic expectations and supports more realistic, layered defenses. Remote administration protocols and file-sharing technologies often become central during incidents, so managers need to recognize them and understand why they are sensitive. Secure Shell, SSH, is a common protocol for remote administration, especially for servers, and it can be used safely when access is tightly controlled and monitored. Remote Desktop Protocol, RDP, enables graphical remote access and can be a strong productivity tool, but it is also a common target for attackers when exposed or weakly secured. Server Message Block, SMB, supports file sharing and network resource access and is frequently involved in lateral movement and ransomware spread when segmentation and permissions are weak. The manager-level insight is that these technologies are powerful because they enable control and access, and power is exactly what attackers want. Therefore, strong design usually limits where these protocols are allowed, enforces strong authentication, and monitors usage patterns for anomalies. Managers should understand the difference between legitimate administrative use, which is expected in controlled contexts, and broad availability, which increases exposure. They should also appreciate that disabling these protocols entirely is often unrealistic, so the practical goal is controlled use rather than wishful elimination. When managers can discuss remote administration technologies confidently, they can evaluate trade-offs like convenience versus exposure and can support investments in monitoring and segmentation that reduce abuse. Time and management visibility are less exciting topics, but they are critical dependencies that often determine whether monitoring and investigation succeed. Network Time Protocol, NTP, synchronizes clocks, and without consistent time, logs become unreliable because event ordering cannot be trusted across systems. In incident response, being off by a few minutes can create false theories about what happened first, and being off by hours can make reconstruction nearly impossible. Simple Network Management Protocol, SNMP, is often used to monitor and manage network devices, and it can provide useful operational visibility, but it must be protected because it can reveal sensitive information about device configuration and status. Managers should understand that operational telemetry is part of security because a system that cannot be monitored cannot be trusted. They should also understand that monitoring systems themselves must be secured, since attackers may try to hide by disabling logging, changing time sources, or abusing management interfaces. These dependencies illustrate a broader managerial lesson. Security relies on correct fundamentals, not only on advanced detection. Investing in accurate time, protected management channels, and reliable telemetry often produces more real-world resilience than chasing flashy features. When managers command these basics, they reduce the chance that their organization learns hard lessons during a crisis. As network architectures expand into cloud and hybrid environments, managers must understand how traditional networking ideas translate and where they change. Virtual Private Network, VPN, technology is commonly used to connect remote users or sites, and the manager-level question is not only whether a VPN exists, but what it grants once connected. Internet Protocol Security, IPsec, is a common suite of mechanisms used to secure network traffic at the network layer, often within VPN designs, and it highlights that secure connectivity involves both encryption and authentication. In cloud contexts, many connectivity decisions are expressed as software-defined policies rather than physical cabling, which can be powerful but also introduces risk if policies are misconfigured. Managers should understand that cloud network controls still enforce segmentation, filtering, and inspection concepts, even when the underlying infrastructure is virtual. They should also understand that identity often becomes more central in these environments, because services talk to services and permissions are frequently granted through roles and tokens rather than through fixed network locations. This shift can be confusing for teams that rely only on perimeter thinking, so managers need to encourage designs that maintain clear boundaries and clear access decisions even when systems are not in a single building. When managers can connect these ideas, they can better guide architecture choices that remain secure as the environment evolves. Another technology area managers must command confidently is wireless networking, because it expands the boundary of the network into the physical environment and increases uncertainty about who is connecting. Wireless networks involve radio communication, which means signals can be observed and potentially interfered with outside the building, and that makes strong authentication and encryption especially important. Wi-Fi Protected Access, WPA, is a family of mechanisms used to secure wireless access, and the manager-level takeaway is that wireless security depends on both strong encryption and strong access control, not on hiding the network name or relying on shared secrets indefinitely. Wireless also introduces guest access and device diversity, including personal devices and Internet of Things, IoT, devices that may have weak security. This is where segmentation becomes extremely practical, because you can place less trusted devices in separate zones with limited access paths, reducing the chance that a compromised device becomes a bridge to critical systems. Managers should also understand that wireless access decisions can be tied to identity and device posture, which supports a more modern trust model. When wireless is treated as a first-class part of the network architecture rather than a convenience add-on, control placement becomes clearer and risk becomes easier to manage. Confident managers can then ask questions like which devices are allowed, what they can reach, and how anomalies are detected, instead of assuming wireless is simply on or off. All of these protocols and technologies become more manageable when a manager learns to ask a consistent set of clarifying questions that reveal risk without getting lost in detail. The first question is what needs to communicate with what, because unnecessary connectivity is the easiest risk to remove. The second question is what trust assumptions are being made, such as whether internal traffic is treated as safe or whether identity is verified at each access point. The third question is where enforcement happens, because enforcement points determine whether segmentation and filtering are real or merely described. The fourth question is what visibility exists, because visibility determines whether incidents can be detected and investigated promptly. The fifth question is what happens when something fails, because resilience determines whether a compromise spreads widely or is contained. Managers do not need to answer these questions alone, but they should be able to ask them confidently and recognize when answers are vague, inconsistent, or overly optimistic. This questioning skill is what turns protocol knowledge into leadership value, because it helps steer teams toward designs that are both safer and more maintainable. When managers focus on flows, trust, enforcement, and visibility, they can engage deeply without micromanaging implementation. As you bring this together, remember that managers command networking protocols and technologies not to show technical brilliance, but to make sound decisions and reduce avoidable confusion. The layered view of networking helps you separate connectivity problems from application problems and helps you place controls where they make sense. Understanding TCP, UDP, DNS, and DHCP gives you clarity on how connections are formed, named, and configured, which supports both troubleshooting and threat reasoning. Understanding segmentation through concepts like VLAN design and controlled routing helps you limit lateral movement and build realistic boundaries. Understanding filtering, NAT implications, and inspection trade-offs under TLS helps you plan enforcement and visibility without relying on unrealistic expectations. Recognizing web, email, remote administration, time synchronization, management visibility, secure remote connectivity, and wireless risks helps you anticipate where incidents often start and how they spread. Most importantly, these concepts let you ask the right questions, demand evidence, and guide architecture toward least privilege and resilience. That is what confident network literacy looks like for managers, and it becomes one of the strongest foundations for making security decisions that hold up under pressure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.